delete a node from rear end. Rear end means this is your list, yes, and this is what from the rear means at the last, right? The last node you have to delete. That is nothing but from the rear end you are going to delete the list. Then what are the cases? If the list doesn't exist means same condition. If first equal to null, return the list is empty, yes. Then if the list exists, then what you have to do? Let's see the cases. First case is if list is empty, right? That is if list is empty like this is what you were. The first is holding the null, yes, this is holding the null. So if list is empty, that is if first equal to null, the list is empty, return null. Case 2, the list contains only one. That is if it consists only one limb field, then you have to delete it one, right? And what this first will becomes first of info. So see here, the list contains only one node. You are consisting of only one node here. Then here this is what your first of info, and first of link is holding null. Before deleting what? If first of link equal to null, right? You are fetching the first of info, free the first, return null. This is what the second case. First case is if the list is empty, you already know the first equal to null, list is empty, return null. If your list consists only one node and you have to delete that, then this will the first is pointing the first node, yes, it consists the value 10. Then what you have to delete? You have to delete this, right? In order to delete, you have to fetch the information which is deleted, right? Then this one will becomes first of info, first of link. What's the condition? First of link equal to null. See here, you are checking the condition, right? If first of link equal to null, delete the first of info. Then by using free function, free the first, return null. The second case is what? The list consists more than one node. Here we have three nodes, yes. Let's see what are the steps we have to follow here. To delete a last node, that is we are going to delete now which one? 60, right? In order to delete a last node, we should know the address of the last node and last but one node. So we use two pointer variables. Which are the two pointer variables we are using here? Current and the previous. Yes, initially current points to the first node. Then what happens here? The current is pointing to the first node, previous points to the null. See how it is, how we will diagrammatically. Previous equal to null, the first is, the current is pointing to the first, right? Now let's look how it is going to be. Look, the first is pointing to the first node, the current is also pointing to the first. Then this previous is holding which? It is holding the null. Then what is the second step? Now update the current. This is your current, right? And previous, so that current contains the address of the last node and previous contain the address of the last but one node. See here what happens here. We will, with the help of current, we will move here and here. Yes, the current points to the last node and previous is holding the address of the last but one node. This is the last, this is holded by current, and last but one node is holded by the which variable? That is previous. Previous contain the address of the last but one node. This can be achieved. How the code we have to write here? While current of link not equal to null, yes, then what you have to do? Current previous, then we have to move from current of link equal to current. Let's see current. This one is a current. See here first. Is current of link not equal to null? No, current of link is not equal to null. Then what happens? We have to move. Then the current moves further. Then it will enters into the loop, right? Then this current is here. Yes. Then again what you have written? This, see here, the current becomes previous. This current will becomes previous and current of link. This one will becomes current. Is current of link not equal to null? No, current of link is not equal to null. Then the current moves here. Yes, then this one will becomes the current. Yes, see here, don't get confusion here. Here काय केला तुम्ही, फर्स्टला करंट म्हणून घेतला, इथं फर्स्ट आला, इथंच पण करंट आलं. आता मूव करायचं आहे. आता मूव केल्यानंतर काय होतं आहे, हे करंट आलं, इथं कंडिशन करंट ऑफ लिंक. हे करंट ऑफ लिंक नल आहे? नाही, करंट ऑफ लिंक नाही, नल आहे. नाही नल असलं तर काय जातं आहे, आतमध्ये जातं आहे. आता हे करंटला काय म्हणून समजून घ्या, ह्याला प्रिव्हियस म्हणून समजून घ्या, ह्याला काय समजून घ्या, करंट म्हणून समजून घ्या. आता इथं आल्यानंतर परत हे लूप एक्झिक्यूट होत आहे. इज करंट ऑफ लिंक नॉट इक्वल टू नल? येस, करंट ऑफ लिंक इज नॉट इक्वल टू नल. आता काय होतं आहे, परत आतमध्ये येतो, आतमध्ये आल्यानंतर हे प्रिव्हियस होतं आहे, हे करंट होतं आहे. झालं. आफ्टर दॅट, आफ्टर एक्झिक्युटिंग द अबव कोड, आता आलं, इथं फर्स्टच राहिलं, इथं प्रिव्हियस आलं, इथंपर्यंत आलो. इथंपर्यंत आल्यानंतर वॉट्स द स्टेप 3? To delete the last node pointed by the current, the function free is used. How to free? If the you will get up to this, then current of link is equal to null, right? Then we can't. After that, what's the information, what's the message you have to print that current of info free. Which one? Current. Yes, you have freed. After executing the above statement, this one will be executed. The step 4 is, आता हे डिलीट झाल्यानंतर लास्ट नोड कधी समजस, when you will come to know that it is a last node, when the node is holding the null value, right? Correct, that is the link field is holding the null value. We have to update this. After deleting this 50 is becomes the last node, right? Then this link must hold nulls. That's why what you have written the code, previous of link equal to null. Finally, which one to return? We have to move to the first, right? Return the first. This is what you are deleting from the rear end. Thank you.